heavier. It can handle data that Excel cannot handle it, right? Also, it is compatible with Python. Once you convert your data set, your CSV or your text file to a Panda data frame, there is a lot of stuff, a lot of manipulation that you can do with it, right? So first, I'm gonna import the library that will allow me to build, create, manipulate our Panda data frame. So I'm going to import, of course, pandas. As PD, right? Because I don't want to write pandas all the time. So pandas as PD, right? So everywhere you see PD, that means I'm calling pandas. And then also I might be using some array to build my data. So I'm going to import NumPy. So I will use some NumPy, right? So NumPy as NP by convention. Okay, so I want to create some data frame. I want to start with a series, creating. So series first. So a series is just a data frame with one column, right? So only one column is called a series. So I want to build off a list, right? First, let me create the labels. So the label will also be a list. Let's assume that the label here is capital A, capital B, capital C, right? And then I want to create my list. So I'll just set it equal to number 1, 2, 3, or let me just put 10, 20, 30, for example. And then let me create another object. I want to create an array. So I'll call it array is equal. So I will call NumPy. So NP that array.
Yeah, the typing is not showing.
The what is not showing?
Where you are typing the live code and it's not showing. Is the one that we're seeing is codes that have been written already.
Oh.
Yeah, so your screen is not moving. It's still online. E197. Yes, now we see. Now we see. Okay, now I can see the cursor. So
okay. Yeah. So let me see if I can minimize the windows. Okay, that should be minimized. Okay, so I want to build an erase. So NumPy the erase again. I want to have the same dimension like my labels here. So the erase, and then I can pick some values for the erase. So let's say 20, 10, and then -5, for example. And also, let me create a dictionary. Dictionary equal to, so remember, dictionary is a pair key value, and then within the curly bracket. So my first key is A, and then the value for that will be 10. In fact, let me B, and then let me get the same number as my list, and then C, 30. Right, let me be persistent here. So let me make this one 10, 20, 30. The thing is, I want to show that you can build your series of each one of these objects, right? But let me first run it, right? So to build your series, you will say PDs, the series, capital S, and then you will fill in your data, right? So you say data equal my list. If you don't specify the index, so let me just write what will happen. I didn't specify the index, so the index becomes 0, 1, 2, 3, right? But if I specify, for example, index equal label, then my index will become ABCD. right? So we can do that. Can you see you still see, right? You see my live code?
Yes, yes.
Oh, okay. So PD, now this time I can build it of the array. I can build it of my list. So PD dot series, and then data equal my list. So data equal my list. That's the same thing. And then I can build it of an array. So PD dot series, and then data equal array. So again, I didn't specify the index here. So if I want the index to be equal to the label, then I will just mention here. Let's say, for example, let me just type, so PD dot series. So the data is an array, index equal labels. So it's the index instead of 0, 1, 2, 3, 0, 1, 2, it become ABCD. Right. So the dictionary is interesting. You don't need to specify the index because that, it already have it there. You just type PD dot series, and then it will take your dictionary. What name did I give it to? My dict. Okay, dict. I hope it's not a keyword. Let me. Okay, it looks like a keyword. So let me do that to avoid any conflict. Right, then directly you will take your key as the index, right? And then your value will be the column value, right? So let's look at another example. So let's say I have the following series, right? So I have the index is equal to this, right? Well, you can reset the index to whatever you want, right? Index equal true, you can reset the index, but series alone is not that interesting. It becomes more interesting, especially when you have a collection of series. A collection series is nothing but a data frame, right? So collection of series. So let's learn how to make this data frame from scratch instead of series. So we're gonna have a collection of them. So I will need a random. I want to build my random data frame. So I will say df is equal to PD that data frame, right? And then here I will call my run n, right? So np so run n. So this will return a sample of a sample that is normally distributed. I think I have a lot of messages here. GitHub update. Okay.
I think most of it have been answered.
Huh?
Most of the questions have been answered. So
okay. I wasn't paying attention. So I want to have a 5 row, for example, and then 4 columns. So I need the index should be 5 also. So I will say index, right? So you have many ways to construct it. You can say index is equal, you can have a list, but here I want to get my ABCD also. So A, B, C, D, 5, so E. So I want to split this, that split. When I split them, I want to split them on empty string. I'll write this empty string here. I want to split them on that, right? So that will be, so the first value will be A, second, right? First row will be A, second B, third C, and so on. Now I want the columns, I can build the same thing. I would say columns, columns equal, I can take X, Y, Z, W, I need 4 of them, right? X, Y, Z, so W, X, Y, Z, that's 4. And then that splits. I want to split them on the anti-split. On the anti-split. So I'm building my data frame of that. If I want to see, I need to look at it here, right? DF round N is not round on, is round N. Okay. Okay, what?
The quotes, there's a double quote and a single quote on a split.
Oh, hold on. The quote should be, let me see here. Just
yeah, I think your code is fine. I think when you say random round N, you say round N.
Oh,
what does that? Yeah, because I
5.
think
Yeah,
that
let me
more,
see.
yeah, more than the ABCD.
Yeah.
Round N returns, it will return more.
This is
more items.
5 rows, right?
Yes.
And then 1, 2, 3, 4, 5, right?
5 rows, 4 columns. So
yeah,
it should be ABCD, no E.
A, B,
Because the columns are your variables, right? So the 4 corresponds to the columns.
Oh no!
I think you're fine.
No.
You're fine.
Yeah, the 4 is for the is for XYZ, the index, right? Run and did I import that correctly? Run and let me run it again. Let me see what it's saying here. Shape. Oh, this is 5 by 4. It said this is index 5 by 5. Is that right? X, Y, Z. We got 4, 5 here and 4 here. Let me change it to 5. Huh. But this is not 5. I don't have 5 column here. Oh.
4. You have yeah.
Oh, maybe that empty, I forgot that empty space.
Yeah.
That's why the empty space. Now, yeah, that was a problem. So space mean a string in Python, right? So we can do a lot of stuff with these. We can grab whatever we want, right? So let's play a little bit with this. So we can let's say you want to grab the last row. So you will say df at let me grab the column first. If I want to grab let's say just by what. So this it will return this. If I want to grab more than one column, so I need to put this in the list. So Y, let's say I want to grab column Y and Z. So this will be Z here, right? And let's say I want to grab a, oh, by the way, this is the same thing. If you are just selecting a columns, right? For example, you have this that Z is the same thing as df at Z, right? So you just, if you are getting only one of them, you can just say that, right? It's the same thing, you get the same thing. So now you can now impose a lot of condition here, right? Again, if you try the type of this, you will see that it is a series, right? Because it's just one column. So let me say type is a series, right? So type of this is a Panda series. So now let's build some new columns, of this. So we can say df new column, for example, or let me put in capital, df new, right? Because ABC, XYZ. So I can say that is a df at the current X, for example, plus df at a column, which one I didn't, W, right? I didn't touch W, for example. And then if you look at your df again, you will see that new column there, right? Come at the end. So you can drop that, right? So there is a drop method. If let's say we add this by mistake, we can drop it. So if you want to drop that new, you can say df.drop, and then you tell the name of the column. So that's X, new. So we want to drop the new, right? So you gotta set that you want to drop the entire column. So that is axis equal 1. Axis equal 1, you want to drop the entire columns. And then you want it to be permanent. Let me do this first. And then we want it here, df again, new reappear, right? So you want it, if you want it to be permanent, then you have to say in place equal true, right? Then when you look at it, new is gone forever, right? Okay, so you can drop also a row, right? So let's say I want to drop 0, right? I will say df.drop, and then I will specify the name of the row, which is C. Now, because I'm dropping the row, then I have to say axis equal 0. This will drop the entire zeros. So C is done. Right, but if I run it again, you will see, because I didn't say in place equal true, so C reappear again. Right. So we can do some more operation. So for example, if I want to return df, I want to grab the place where W, df of W is bigger than 0. So for example, if I run this like this, it will just give me true or false. True where it is true, then false. Now, if I apply df, a data frame to that, it will return the value where this is true, and then it will return NA where this is false. So basically, we'll only have 2 values. The rest of them will be NA. Only W positive. Okay, so it didn't show the rest of them. Let me look at it. So you only give me the rows and columns where W is positive. You return the rows where W is positive. Okay. So now we can impose condition modes to more than one column. Let's say I want W to be, so I want this W first of all to be greater than, let's say 0, and I can grab only some column, let's say greater than -1, that might be all of them, greater than 1.2, for example. If I do that, that will be a restriction. So now, from off that, you can grab whatever column that you want. So let's apply df here, right? Once you apply df to it, you can grab, let's say I want to grab a column X and column Z. So you just column X, column Z. So this should only give me one. Hold on. Yeah, this is a list of 4 columns. So you gotta put them in square brackets. DF bigger than 1.2. Let me look at this. Z, small z, it has to be capital. Yeah, right. So only one row, because this is the only place where W is bigger than 1.2, right? So I'm returning X and Z, so these two numbers, right? So, what else? So now let's move on to multiple index. Right? Let's say you have a data frame, inner index and an outer index. So we put here multiple index. Right. Okay, let me just put it that way. So let me make this one as a markdown cell down here, and then change this cell to a markdown. Right. So for example, we have this list. Right. Let me run them. So my inside index will be this. My outside index will be G's. Right. And then let me build a data frame of these. Right here, I'm zipping the inner and the out. If in fact, let me run this. It will return the pair of inner and outer index, right? So G1, 1, 2, 3, 1, 2, 3. So G's are out there, and then 1, 2, 3 are inner index. So now I want to build a data frame of these, right? So I can say Panda the data frame. Let me PD the data frame. Right now, I will fit in these there. So NP, I want to NP the random. I want to build a random numbers, but my index are already set for. So NP the random, the run end. So run end will return a sample that is normally distributed, right? So let's say I want 6 by 2, right? I have to make sure this is 6. 1, 2, 3, 4, 5, 6. Yeah, so that makes sense. 6 rows, 2 columns. So 6 by 2. And then my index, let me just copy these. Index equal this. So index equal that. And then the columns equal this. I want to give name to the columns. So capital A, for example, capital B, and that should do it. Let me see. Did I give a name to it? No, I gotta say, call it, for example, DF. So DF equal this. And then if you want to see, then we need to look at the data frame. So if you want to grab something inside here, so you gotta consider the outer index and the inner index, right? For example, if I want to grab G's only, right? If I want to grab the G only, so I can use something called LOC. So I will say my df.loc. So we are grabbing by location, and then I will just specify the outer index, but it contains the inner index, right? And then that will give me all the G1. Now I can also specify if I want to grab the first row, but I gotta be careful here. The first row, the index is 1, not, it doesn't start at 0. So if I want to grab the first row, I'll just do this. This will return G1, oh, LOC, right? That LOC, oh, lowercase LOC. So this will return the first row, right? A value is here, and then B value is here. So you remember, if you look at the index, they don't have name, right? We can check that. We can check df the index that name, right? If we run that, you will see they don't have names. So we can give name to them. So we can get the same thing and then set it to whatever name that you want. So I will say this equal some name. Let's give a name. So the first one can be group, and then the second one can be number. And then once you do that, if you look at your DF again, you will see that the index have name, right? Again, you can do a lot of stuff here. Let's say you want to only grab by level, right? So you can do that. But these are fake data set that I create. I want to get a data that is very similar to real life, and I do some exercise to that. But before that, we need to talk about some operations that you will be doing with data set as a data scientist, like join, merge, and concatenate, right? So let me build some data frame. So I will say this data frame here. So this is what we're going to do. We're going to talk about merging, concatenating, and joining. So that's what we're going to do. So clearly we need more than one data frame. So let's say this data frame, right, is defined as the following, and the index are 0, 1, 2, 3. Right. So if you look at that DF1, right, so you got 4 columns and then 4 rows. Now I want to build a similar data frame to that. So I will say data frame 2. So to be quicker, I just copy this and paste. DF2. So you can concatenate these, you can merge them, you can join them. Let me add a third one. So DF3 is equal, I'll just change same dimension. Okay, so DF3, like that. So with this data frame, like I mentioned, we can concatenate them, right? So if I want to concatenate these 2 or 3 of them, all you need to do is to call pandas, right? So let's say concatenate concats. Right. So we want to concatenate concatenations. So you do PD, you call PD, right? That's concat. And then you call your data frame. So DF1, DF2, DF3. I think that's it. Right. So if you don't specify how you are concatenate them, then it will do them by row. So for 1 and then 2 will be below that, and then 3 will be below that, right? Because I didn't specify. This has to be in list. Is a list of data frame. That's why you get this. So once you put in the list, then it should be fine, right? So DF1 is on top, 2 is in the middle, and then 3 is at the bottom. So now if you want them to be joined by columns, then you gotta specify axis equal 1. Right, so let me copy these and then specify axis equal 1. So I will say here, I want to join these by columns. So X is equal to Y. So it will be different. The output will be different. So DF1 got only 4 columns, 4 rows. So the remaining rows will be NA. Right. So DF2, it has 4 rows, but the index start at the position 4. So anything before that and anything after index 7 will be NA, and so on. Right. So we can also do join, or you can join data frame. So let me build another data frame. All right. So let's say we have these 2 data frame, right? And I want to join them. If you look at these 2, let's say left, this you got 2 key here, key 1, key 2. If you compare it to right, they have the same key. So we can join these, right? You can join them by and merge them by key. By those keys, they are similar, right? So one way to join these is to write the following code. Right, so you will call Panda as always if you want to merge this PD that merge. So now you call your data frame. So left, right, how you want to join them. So left, right, and then on keys. So these 2. So I would say key 1, key 2. Right, and that should do it. That set that to any, yeah. So we join them, using these 2 keys. They have the same key. Let me look at the message. Yeah, Z is smaller case. Thank you. So the data number. Okay. All right. So most of those questions have been answered already. Now you can also merge, join. This is merge. So let's do join and then go to a particular data set. Copy these. So we want to do merging. Now that's merging. So join, joining. So again, I have 2 data sets here, right? I want to join them, right? So for joining, you can just, let me run this. So if you look at left, right? If you look at the right, now I can join them. So if you can say left that join right, and then if you don't specify anything, it will just do the join. Now you can say outer. If you say outer join, then it will do the outer join. So after you do left that join right, and then you say how, you got the how parameters, how equal outer, outer. So they should be different now. So now I am ready to use a real data set. Right, so close to reality. So there is a data set I will be sending to Nana called salary. So we're gonna do some exercise on that. But there are so many things that Panda can do. So it's good to use it with a data that is similar to the reality. So I already import Panda. So what I'm going to do, I'm going to convert the CSV file to a Panda data frame. Right. So again, I would call DF, or you can call it salary. You can give a name. Usually you name your variable so that it will remind you what it is. So you can call it salary DF, right? And you know that is about salary, right? This is about salary. So I would say is equal PD that read underscore CSV. This is a very important function in pandas. Read underscore CSV. Now I need to specify the name of the CSV file. Salary, I believe that's CSV. Right. So this line right here will convert my CSV file to a Panda data frame. Right. If I want to see, then I need to look at the head of the data set. Right. So it gives me the first 5 rows of the data set. Right. But if you're repeating this, you have to make sure your data set is in the same location with where you open your Jupyter notebook. If it's not, then you have to add the path here, like C, right? Whatever it is, you gotta add the path. Otherwise, you will not see it, right? For example, if I change this to something that is not in my folder, I'll get this error, right? It's not there, it doesn't know. File not found, error. Right. So that's very important. Your file and the Jupyter notebook should be in the same folder, right? So this returns the first 5 rows of a data frame, the head method, right? So there is a method also called, let me have a lot of empty cell. There is another method called a tail method. So this will return the last 5 rows of your data frame. So as you can see, this data frame content, base pay, job title, employee name, overtimes, and so on. But if you look at the benefit, it has a lot of NAs, right? So as a data scientist, you're working on a data thing. The first thing, it is very important to check for any missing data in your data set, right? So one way to do that is to run the following. So df that is NA, right? So it's a method. Now, if you want to know the sum of missing data on every row, then you got to add the sum method to it. Right? So this will tell you the base pay missing 609, the benefits is missing a lot, 36,000, and then the notes is missing. So how do I know that this column is missing almost all of them? So if you want to know that, you need to check the dimension of your data frame, right? You remember this is like a matrix. So your df that shape, this will return, it said that you got 148,654 rows, right? So that's exactly how many is missing here, right? How many are missing here, and then how many are, so that means these 2 columns are useless, right? They will not bring any useful information to your analysis. So you can drop those 2 columns. The ID, if you look at your data frame, the ID is the same thing as the index, right? They are the same. So if you want to keep it, you can, but usually these are the same. So you can drop the ID. The ID will not tell you anything about somebody pay, right? This is just the number 1, 2, 3, 4, 5, right? So you can drop those useless columns, but look at the benefits. You don't want to drop these, right? Because not all of them are 0. And then this is less than, let me do this. 36,36163 divided by 14,8654. If I divide that, it's less than 80%, only 24%, right? So you will not drop these, right? So one way to, handle this situation is to replace the missing one by 0. Some people will replace it by the mean, and then so on, right? So some employee might not have this extra benefit, so it's your call. So we not drop these, but we can replace those NA by 0, for example. Right? Base pay here, same thing. It's very tiny, right? So let's see if we can drop those columns. We have a ID, notes, and status. So let's drop those. The shape will change. This is a 13 column. So if I do df.drop, and then I have a list of columns. So the first one is ID. Second one is notes. After notes, status. Again, I want to draw the entire column, so I will say axis equal 1, right? So if I do this, and then 1, you see right now, where are them? They are gone, but if I run it again, let me minimize this. Okay, up to agency. They are gone, but if I run it again, you will see, let me make this one head. I want to just take the head so that there's less space, more space. Head, just 1, right? So now if I run it again, 1, if I run this again, you will see that pop up because I didn't say in place equal true. In place equal true, right? Once you do the, oh, it's not there already. Let me move this because I just deleted it. So let me come here. Okay, so now if I look at it again, I set in place equal true is gone forever, even if I look at it again, right? But if I delete it and then try to delete it again, then I will get error, right? Yeah, the same thing, I try to drop it. These will not exist, so do not run them twice. Then they don't exist, you get error message, right? That's the same thing when you add a column and then you run it again, you run it again, you will add the same column that many times. So I've done that. So we delete those. We can easily check now the shape. So df.shape, you will see that the shape has changed from 13 to that. Now, I said I'm going to replace the NA by 0. So this is how you do that. So df dot, right, is NA, I'm not fill NA. That's a method fill NA, and then you gotta specify the value. So I would say value equals 0, right? In fact, before I do that, let me run our df that is NA here. That's sum, right? So 1, 2, 3, 4 columns has NA. But if I do this, let me copy this. Right. So I do that, and then let me get the head only. I don't want to see this head only 1. Now I want to run it again to see if there are any missing data. So df that is NA, that sum, you see, oh, in place equal true, right? In place equal true. Yeah, let me take this out. Right, so now I don't need this off. What did I? Okay, in place equal true. I'll run it. Now there is no more NA. All the NAs are gone, right? So this is one way to clean this thing. Now, from the previous data frame, we were grabbing specific columns. We can do the same thing here. Let's say I want to grab the base pair, right, of this data frame. I can just do df either that base pair, that will return that, or df at the base pair. So here is a string. Right, so that is if I want to grab only that columns. Right. So now there is a method called columns that will return the name of your columns, right? So df.columns. So let me, some people use df.columns, that name or that value, but columns will do the same thing, right? If you want to know the name of your columns, you run this, then it will return a list of that contain all the columns, right? So let's say you don't want, yes. Yes. Okay. So let's say I want to grab only the column that have a numerical values. So I can just say df. So I'm gonna get this list here. For example, I know the one that contain numerical value. For example, I know employee name is not there, job title is not there. That so. And you're an agency. Right. So you apply df to this, it should return only those with numerical data, right? So when I look at this, it seems to me this total pay benefit is the sum of these, base pay plus this plus that, right? And is equal to this to me. But you can check that out, right? You can check, you can add those columns, right? So this is the hard way to do it. You can say new, I can create a new df at new. So let's add new is equal df. So what I'm going to do, I'm going to get df at base pair plus df at overtime, hit up, plus df at order pay. So order pay. Okay. So let me run this and then look at df new. Let me look at the whole data frame that here, for example. So the new should be the last columns. Let me come here. Yeah. So we can compare it to the total pay benefits, right? They are the same, right? Because this will be different from this sometime. We can check that too. But let's work on this new column. Let's say we don't want the position here, right? Is at the end. I want to get it next to total pay benefits. I want to get it next to that, and then so that I will be able to compare them side by side. So again, to do that, you need to get your column name. There are many ways to do that, right? So let me do it the easiest way. So you do df.columns again. You get this, and then you will say df is equal this. You reorganize this. So I want this new to be next to this total pay, right? So that once I've done that, then I will be able to compare them side by side, because there are one column between them is not that easy. And so that's one way to do that, right? Once you switch, but you gotta apply the data frame to the columns. It's a list, then we need to apply the data frame to it. So df is equal df that I reorganize the columns, right? So I move this here, and then if we look at df, that head, I believe they should be next to each other. Total pay and new are next to each other here, right? So you can compare them side by side. Are they the same, right? Let me go to tell. Look at the tail, right? That seems to be the same. So now, let's do it another way, right? So I can go by columns, by hard coding the columns. So let me define a variable called columns. So I'll say calls equal df that columns, right? Df that column. So I want to get it as a list. So list of the, right? Df that columns. Right. So now I want to go by columns. So let's say I want to move this year to next to new, and then new go to the last columns, right? So what I will do, I will say df is equal df, right? So I will grab it by column. So that call, so I will count, right? So I'll start here 0, 1, 2, 3, 4, 5, 6, 7, right? So up to the 7 index, right? So let me remove this. So from 0 up to 7 index, right? So that will be 0, 1, 2, 3, 4, 5, 6, 7. Right, so to 7. Now I'm gonna add that to the last columns. So that is df, right, at columns. So the last column is -1, right? This df, so these columns at -1, that will return the last one, -1. Negative, the index negative will return the last one. Now, plus, now the one that is at the index 7. So call, right, at index 7 to 8. So 7 to 8, this will just return 7th one, right? Let me see, 0, 1, 2, 3, 4, 5, 6, 7. Right. And this will become 8. I will add this, and then this position will be at the last one. So that's it. How many columns I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10. So 1, 2, 3, 4, 5, 6, 7, 8. So up to 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then this one go to from 8 to 9. So let's see. Okay. It said it can only concatenate lists, right? This is a list. This is also a list, right? But the only one that is not a list, let me control Z here. The only one that is not a list is this single one here, right? Just a series. So you consider that as a string. So you just put it, you know, list is between square brackets. I believe that should do it, not a string. Okay, so let's run this and then let's look at the df that had, right? So, yeah, the new is, you know, we move it to the end again, right? Okay, so now I add the columns value earlier here. What is it? Yeah, add them like this. You can also add them using the index location iloc, right? So let me show you that. So you can say total. Okay. So I want to create a new thing called total. Total. So I'm adding, right? Let me make this one one so that I'll be able to see the column's name easily. So I'm creating a new columns called total, and then that total, what I'm doing, I'm gonna add this base pair overtime order pair benefit right up to here. Right. So from I will be using iloc. The thing is with iloc, it will include the start point, the end point. iloc will include the end point. So I have to be careful when I'm slicing. So df.iloc is stands for integer location. iloc. So now I want all the rows. So all the rows mean this. Now my numerical values start at index 2 because this is index 0, index 1. So 2, from 2, 3, 4, 5, 6. Right? So no, this is not part of it. 3, 4, 2, 3, 4, 5. Right? Up to 5. Let me see. So let me look at df head again. If total, I'm taking the sum, right? Sum, right, on the columns. So I will say x is equal 1. I forgot about that. Let's see again. Let me look at it. Let's look at it's exactly equal to the new, right? So this is one way to do it using the iloc method. Okay. Let me. Right. So again, we can drop these two columns if we want, right? And we can drop any rows that we want, right? So in fact, let's do that because we just add extra. We can drop them. So df.drop. That's df.drop. We have a list of columns. So what's the name? New and total. So new total. Right. So I'm dropping the entire columns. Axis equal 1, in place equal true. Right. So if I look at the head again, that should be gone. Right. So agency is a live thing. Okay. Now we can, what if we want to select all the employee name, right? So we can do that using employee name. We can also do that using the integer location, right? We can use that. Okay, so let's say we want to grab the first row using the integer location. How we do that? So you just grab df.iloc0, df.iloc. Okay, let me see that message. Yeah. Yeah, you can. Absolutely. Yeah, there had to be a list X. What is it? Oh, you are iterated. Yeah, that's fine too. Right. So df, what I was going to grab the first row, the iloc. Right. So you just the first row is at index 0. That's it. That should return the employee that is out of the first row, right? Nathaniel. Right. So he will tell you his name, job title, base pay, overtime, other pay, benefits, right? And the location, San Francisco. Right. So if I want to grab with iloc, you can grab whatever you want. Let's say on the D, let me look at df again. Df the head. Right. So maybe this one 2 only. Right. So let's say I want to grab these columns. Right. I want to grab these columns only. So I need to specify if I want all the rows. I think I did that already. Let me see. It looks like this. This is rows only. So if I want to grab the entire column, let's say I want to grab the base pay. Right. One way to do it is df at the base pay. Right. We did that. And then another way is to use integer locations, df the iloc. Right. So now you want all the rows. So comma, and then the columns start at index what? 0, 1, 2, index 2. So 2 to 3, and that's it. That should be base pay. It's the same thing as df that base pay. Same thing. Right now, let's say we want to print all the employee, right? The name of all the employee. We want to go through all the road and then read the employee name and then return it. So there is a method called ethero road. Let me do that here. So we'll say, so ethero, let me write it down. Ethero, this will return couples of index and value. So in this case, it will return index and the name. I'm going to look for that, right? So I'm going to use the method here. So I will say for index, IDX, and name. Let me just go by rows. I would say rows, right? In df dot ether row s at the end, right? So if you look at df ether row, you will see it's a couples, tuples of Control Z. So for index and row in here, then we want to print them. We want to print the index, IDX. We also want to print the rows, right? And remember, if you look at a row, it has many stuff. If you look at this row, the employee name, job title, base pair, and so on. So we want to grab only the first one. So first one means employee name. That's the first entry. So I will say row at employee name. Employee name. Okay. Right. One employee name. If I want to grab only the first name, let me run this first. Right. So it give me the full name. So if I want to grab the first name, right? If I want to grab that, then I can see this is the name of everybody that's here. Here you can check the most popular name, the least popular name, check if your name is in there, right? And so on. So if I want to grab only the first part, because this is a list, it's a string, so I'm gonna split it first. So that split, right? If you look at the first name, last name, there is a just a space between them. So I will say split on the empty space. And then once you split it, give me the first one. So that will give you the first name of everybody. Right, so first name of everybody. So if you want the last name of everybody, you split it, you turn that. Okay. So let me help this cell here. Cell, current cell. I want to clear the current cell. Okay, it gave me the result already. Okay, there is a text. Can you please take a break? Okay, that's fine. So 15-minute break.
Okay, cool. No, yes. Okay, sure. So 15, we have 12, 15. So we convene back at 12, 11. So let's make it. So Dr. Musa, it's your call. So you decide when you want us back.
Yeah, 15 minutes is fine. So 12:26.
Okay, cool.
Okay. Thank you.
Okay, thanks. Bye. Okay, Dr. Musa. So I think we're on the 1230 line, and we remain consistent at 25 working days. So, set it up.
All right, so let's continue. So let's say I want to get employee who makes more than $500,000. Right, so I can easily do that by using the log method. So df the log, I want to take total pay benefit, total pay benefit. Should go to complete benefit. We want to impose a condition on that. So we want to say that should be bigger than 500,000. So let me copy these. So df at that. So if you take that columns, we want the columns value to be bigger than 500,000. 1, 2, 3. So only 2 people, right? Only 2 people make more than that. So let me go to the, yep. Or 3 people, yeah. So now I can sort, right? Sort the data, let me say here, sorting. So make that as a markdown cell. Can you see the Jupyter notebook that I'm typing? Okay, good. So now I want to sort it. So I want to sort by name. So I will say df.sort, sort value underscore value. And then I want to sort by employee name, for example, employee name. So I can do that, or I can also sort a list, right? A list of columns. So instead of employee, let me do the employee only, and I will do employee and then the salary. So employee, and then I want to make sure that ascending. I can set this to true or false. So it depends on how you want it. So assigning equal false. So in this case, it will go from biggest to smallest, right? So I want to look at the head only. I don't want to print the whole thing. So let me look at the head. So look at this. So from so let me set this equal false so that it will become the other way around. Right. So from biggest to smallest. Oh, where am I? Yeah, from biggest to smallest. So you can change this to however you want. Now I want to sort, instead of 1 column at the time, I want to sort 2 columns. Let's say I want to sort the employee and the total pay, for example. Let me copy these. So there's this here. So employee and then the total pay benefit. Total pay benefits. Right. So, but in this case, we need to be careful because I am sorting 2 columns. Then I can set one to be ascending, the other one to be descending. Right. So, for example, if I want the employee name to be ascending, then I will put 1, and I want the pay to be descending. I'll put 0 there, right? I have a list, so I gotta specify that. Then this should say the name is in ascending order. So start from A, and then the last one will be Z. If I look at the tail, so look at the pay. The pay is like the smallest here. Right. So let me look at the tail. Right. So looking at the tail, we got the last names as Z's, right? And then now the pay there are the biggest. Right. So one can do that. Now, another thing that you can do is to save your data frame, right? So there is a method called toCSV or toExcel, right? You can do that to save your data frame. So here, I know that I'm here, prime working directory. So if I save it, it will go to this folder, right? So I will say df.to CSV, so 2_CSV, and then you give a name, what name you want to save it, right? Your data frame, let's say I want to say my salary, that's CSV. So if I want to save it as a CSV, so CSV, right? Now, I gotta set index equal false. If I don't do that, and if let me do it first and then show you what is happening. Now let me go to the file location. So I click on open here. My salary. Can you see this list? Can you see the window that I just opened? Okay, so you see my salary is here. When I open it, it has this index at the end here, at the beginning, so 0, 1, 2, 3. So if you don't want that, because once you transform this to a data frame, there will be the extract index in there. So if you don't want that, then you will say index equal false. Index equal false, right? Right, so once you do that, then that thing will no longer be there. Now I'm going back to the file location again. So open. So my salary, see the index is no longer there, right? So once you open it, you don't have an extra index. Okay. So in addition to save as a CSV, you can also save as, so let me put it here, save as CSV. Save data frame as a CSV. Okay, so now we're gonna save it as a Excel, right? So save as, so if you wanna save it as Excel, this is what you do. So you will say df the two CSVs, two Excel, df the 2_Excel, and then you give a name that you want to save it. So I will say my Excel here, Excel, right? Then that XLSX. Right. So again, you gotta tell them that you want index to be false. Otherwise, you will have the extra index in there. So index equal false. So let's go back. It's working. Once it's done, then I'm gonna check to make sure there is no extra index in the Excel file. Okay, my characters. Okay, now it's done. Let me make this one bigger a little bit. So now let's check the file location. Open my Excel right here, and there is no additional what? Oh, I need to open with Excel. I got it. So yeah, I need to open with Excel. So need to go in, but you will notice that there will be no additional index in there. So let me. Right. So now we want to save it as TXT. So you will use to CSV, but you have to add the TXT so df dot to CSV, but now your file, so I will say my file dot txt, and then the separator, you want the index to be false, index equal false, and then the separator set equal this tab. So the TXT are tab separated the data. So that's backslash and T. Right. So this will save it. Right. So I'm not sure I can open that too. So my file, if I go to my file that TXT is right here. Let's see if I can open it. Yeah, so I'm able to open that. Right. And then they are separated by the tab. Okay. Okay, so now we know how to save it. We know how to create data frame. We know how to manipulate them. We did some filtering. We can even do some more filtering. Let's say, for example, we want to find employee whose name. So whose name is, let's say, pick a name. So df at employee name. So I will say is equal. For example, Musa. This will not give me anything. Let me put it here. There is no employee in the list that have this name. I will be just an empty data frame. Right. So I can search for other name. So I believe there is somebody named Thomas. Right. Then done. Oh. So if this employee exists, then it should return that thing. Right. Oh, I don't have that either. Okay. So df at employee. So I will do more selection later on. So we already compare. So if you look at the data frame, some of the employee has a base pair equals 0. So if I want to check that, I would say df, right, at base pair. So df at base pair. I don't know what kind of employee are those. That is equal to 0. Right, equal 0. That should return all of them. So if you want to know how many of them has a base pair equal 0, you use the len method that stands for the len. So you got that. Right. So some of them owe the state. So if I use this condition less, because I went through the pair, I saw some people got negative. Let me put head here. If I put head, you will see some people got negative number for the. Some people got negative number. I saw that. Okay, maybe it's down there. But I saw some negative value for the pay, right? So maybe in the original one. Now I want to know if anybody has a pay that is less than 0, for example. Let me do that. Instead of going through this, I can do this. How many of them? So 11 people, right? That means they're just all of the state, right? So if we add a 0 to it, then it might be more. Okay, less or equal to 0, you got 19, 18, employee that are 0 or less than. So you can set this to a new data set. So I can call this one 0 data set or null. Null df is equal to this. So df at this, right? So is equal the data frame. Give me those employee whose pay is less or equal to 0. That's it. So df at base pay. Base pay is less or equal to 0. And then base pay is not defined. df at base pay. Okay. Let me copy and paste. Oh, it's a string, sorry. It's a string. You need to put in the quotation, right? So let's look at, you can look at it. The null df, you can look at it. Since it's not, I think it's a lot, so I want to just do the head, right? So that's the new data set. So you can save these, right, to CSV, to Excel, to your machine, for others purposes. But if I have only less than 0, I think we can just look at the whole thing. It's just 11 people, right? I think we can look at all of them. Less than 0, all of them. You can see them here, right? Okay, so we can save this like we did it last time. Now we can check the number of unique job title. Right, so there is a method called unique, and if you take the length of that, it will tell you the number of unique job title. But instead of using that, you can use n unique also. So let me do the first one. So I want to get a df at the job title, right, and then I will set that unique. Right. So that will return the number of unique job title. So instead of doing that, I can also do df dot n unique. Right. So this should return the same exact job title. Sorry, df dot job title dot n unique. Let me put it in the quotation here. It doesn't take that because I have another method after it. Right. And unique. Right. So it's the same number. Right. Let me see why this does not that. Okay, same thing. The problem was n was missing here. Right, so this will tell you the number of unique job title. Right, so earlier I was trying to search for a specific employee name. I couldn't randomly say it, but I think we can persist. So df.loc. Right, so we want to grab df at employee name. Right, and then those employee name, we want to use that string str that content. So we want to see it contains the word, for example, Musa. Like that. This method is a little bit dangerous. It doesn't give you the employee that have a name Musa, but that content the word MUSA, right? MUSA. So you can change it to John, right? So you got many of them, right? So now if I want to get the exact, right? With Musa, it wasn't exact. With John, right? He has it. Now if I want to get exact, I can use a lambda function to grab the first part, right? And then set that first part to be equal to whatever name I want it to be, right? So if I use that method, and then you will see that the Musa will not return anything. So df that's LOC. Then I want to grab a df at the employee name. Right. So we want to apply. So I will say apply lambda function in there. So lambda, right, and then x. So we're gonna do x dot split. We want to split every name by the empty space, x dot split, and then just collect the first part of it, right? And that's it. So now we're gonna compare the first part to my name, for example. So if I compare it to Musa, you will see that there is nobody equal string. It's empty. But if you do contents, that's not empty. There are a lot of people who name content MUSC, right? And if you want to get, is there anybody named that? Yeah, you got some people named Josh. Okay, so you got many David. So we can also look for you can look for the most popular name, right? You can do that. Right. So in fact, let's do that. The most popular name. So what we're going to do. So let me copy this here. So this, I'm just gonna grab value counts of the employee name, right? In fact, I should have just typed my own code. So df at employee, and I'll just count the value. So that value counts lowercase value, and then count is plural, right? And then this will give me the list. So if I want to get the top 5 popular name or top 10, then I'll do the head method and then it, fill in tender. But this will give me the top 10 most popular name among these employees. Right? So Kevin, Richard, right? John, Victor. So these are the top 10 most popular name in that. Okay. So this is pair. At some point, we will need to find the employee that make more money. So when your data is so big, sometimes it makes sense to work with a chunk of data. I'm pretty sure at some point in your life you will be dealing with a huge data set. So you don't want to load all of them in your memory at the same time. So you can take chunk by chunk, right? So one way to do that is the following. So I will for loop through our data frame. So I would say for, I'll just call this one chunk. For chunk in PD, pandas that read underscore CSV. And I want to call our own data frame, data set salary. Right, so here I will set the chunk size. Right, so chunk size U and size chunk size equal, let's say I want to grab by 5 rows. So I will just say chunk size equal 5. And then column for that, I want to print, for example, then I want to put say chunk here, chunk data, and then I want to print our chunk. All right. So it's a chunk or chunk df. So I'm printing these. So you should go, we should see 5 by 5, PR, what is that? PD, pandas, PD. This salary, that's CSV, okay? Is that CSV? CSV, okay, give me that. All right, so the first chunk, you see 5, and then, right, chunk, you got 5 also, chunk, right? So you will load it chunk by chunk, right? So that's something to know. Now, let's say we want to know the mean of our base salary here, right? So let me write it down. What is, so what is the average base pay? Right. So the average base pay, right? We just grab our data frame, we grab a base pay there, and then we apply the mean to it. Right. So df at base pay, that mean. This will return the average, that mean. I hope this is not still running. Chunk. Okay, df base pair, that mean. Why it takes so long? Let me close some of my windows. Okay, so one thing that you can do is to go to the cell, current cell, and then clear it, right? I don't know why it was taking that long, so I'm gonna do it again. My DF is fine. So base pay is also part of our, let me run it again. Okay, so if that happens, you interrupt the whole thing. And then I wanna, let me clear the whole thing, right? So restart and run all. My computer memory, let me close any additional windows. Close that out. Okay. It's not, it didn't get here yet. So why not? Okay. Invalid syntax is stop here. Why? Oh, we got this. Why this is double here? So when I get to my chunk, I'm gonna skip that part. It looks like okay, this is fine. This is fine. 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 Okay. All this right here. Yeah. Okay, I'm gonna skip that chunk part. Let's say, so we got our DF, yeah, right here. So we can get the mean. We should be base pair, so pair twice. Base pair, that means. So this is the base pair, right? The average base pair for these employee. Okay, so now we want to know what's the maximum over time, right? Maximum over time pair, right? Over time pair. Same thing. So we come here, DF at over time pair, and then you take the max, that max will return the maximum over time pair. Right. Now we need to know the job title for the employee. Let's say we know the employee name. Let me go to you have the employee name. You got, yeah, right here. Okay, so let's say we want to know this guy, for example. Right, I want to know his job title. Right, so let's job title for employee name this. Right, so I know his name, I just want to know his job title. Right, so let me make this one that. So I will definitely need the employee name column. So I will put here employee name. Now I want to set that to be equal to this guy first, John Kanye. And then we are going to, if you run this, that will be true or false. It will be true where it is only one, and then false anywhere else, unless there are many John Kanye. Now, if you apply this to a data frame, so you will return the whole data frame. Now, inside that whole data frame, you can easily grab the job title, right? This data frame has job title. It has a lot of columns. So one of the columns is name is job title. So this should tell us the job title of this John. So it is an inspector, right? Police department. So if you know the job, or you know the specific attribute of an employee, then you can get others attribute about the employee. So we get that. Now we need to know how much does this employee make, right? So John Kanye. So how much does it make, including overtime, everything, right? So basically, we need to know the total pay benefits of this employee, right? So we get this. So how much, right? Joseph Dow make. Gotta be here. So we grab this. Instead of job title, we're gonna replace the job title by total pay benefits. Right. So we replace this by total pay benefits. Total pay benefits. Right. The spelling is correct. Yeah, so this John make 180,000. So we can do a lot of stuff here. We can also look for the person that make more money, the highest pay, right? So highest paid employee. Right. So highest pay employee, just take out the total pay benefits and then you set that to be equal to the max. Right, you got DF here, and you're gonna apply to DF at total pay benefits. Right, total pay benefit, you want it to be equal to at DF at total pay benefits that max. Right, you want the maximum of that, and the max is a method, so you need to have a parentheses there. I think he returned that guy, Anton and Nathaniel. Right, he's making more money than anybody else. Right. Okay. So you can also get the lowest pay, the least pay. Right, to get the least pay, then you can just replace the maximum by the minimum, right? So you can easily replace the maximum by the minimum. So let me put that here. So if you want to know that, then you replace these, copy these, just replace by the minimum. That means. Right. Now, we want to know the average pay base of all employee per year. So from 2000, let's say, let me copy this question and paste it here. So from 2000, let's say from 2011 to 2014, make this one as a markdown cell. That. So we got 11, 12, 13, 14, 4 years. We need to know that. So we need to group this data frame by year first, because we don't have the years together. Everything is just together. So there is a method called group by. So in this method, we're gonna group by years. As soon as we group by years, then the years become the index, right? The years become the index instead of the numbers on the left side. The years become the index. But group by always is followed by aggregated function. If you don't apply aggregated function, you will not see anything, right? It will just tell you that it is a group by object, right? So df dot group by. So I want to group by year, right? So if I do that alone, so let me set that to a variable. For example, I would say group df equal this. So I group by year, group by year. Let me see. df that group by year. Is my year spelling wrong? Group by year. Okay. My year is not here. So what I'm going to do, did I drop that? Okay, let me see. Let me apply this aggregate function first. And then in there, I want to get the base pair. Base pair. I thought there was a column name that. So group by year name. Let me go back to my data frame. Yeah, the years is missing. Let me go to the beginning. I don't have year. Oh, years is here. For some reason, it's not there. Let me, okay. Years is here, right? Let me go down. There is a variable called year. The group by year. Let me look at DF here. What did we do to DF? That had, let me just get this. Yeah, the years is there. So let me just copy this. I don't know why it is complaining about DF group by year. I copy and paste it work. But I type the same thing here. So this will give you the mean of a base pair. So 2011 was this, 2013 was that. So it is 2013 was a good year for the base pair. Right. Now, right, you can store that to a data frame. You can call it a group DF. Right. Now we want to know the top 5 common job. So to get the top 5 common job, we just get the top 5 common job. Right. So you grab the job column, so DF job title, right? And then you do value count, or you do like this, DF dot job title dot value count. And then you want to get the first 5, top 5, so that head. And then you put 5 here. Head usually written with so special nurse transit operator is a top 1. After that, special nurse. After that, registered nurse. After that, public service head, public work, police officer is the 5th one. Okay, so now we want to know how many job titles were represented by only one person, right, in 2013. This is tricky. Let me copy the question here. How many persons? So that means the value count equal 1, right? The value count for that job equal 1, right? That will do the job. So how many people, how many job titles were represented by only one person, right? So meaning if you take the sum of all the value counts, that will give you the number of jobs that were represented by one person, but the value can has to be equal to 1. Right? So you need to, the sum will be, you are adding all of them, but inside the sum, you need to take the data frame that will be acting on the job title, and then we need to go to the years first. So the years equal 2013, right? 2013. Right. So once you apply data frame on that, you get a data frame back. So now we need to grab the column that says job title. Right. Once we get the job title, now we need to count all the job title, the value of all the job title. So for that value count. Right. Of course, if you don't do restriction, this will return, right, the count of all the job. But you want this, the value count to be only 1, so equal 1. But if you set this to 1, then that will do it, right? So you got the job title, you grab it from this, right? If you get this, that's a data frame. Control Z. Right. If you grab that, that's a data frame. And on the data frame, you want to grab job title only right here. Once you grab the job title, let me put head here. Right. So from here, then you grab the job title right here. Once you grab the job title, you count them, and you want the value count to be only 1. Those that repeat only once. So let's see how many are there. That values count. So DF is applying to this. I want to make sure I close all the square bracket. Equal 2013, job title, value count, equal 1. Yeah, let me look at the error message, what it said. Job title. So this will look different. Let me run it again. Yeah. So there are 202 jobs that were held by one person only in 2013. Right. So now we want to find out how many people have the word chief in their job title. How many people have the word chief in the job title? Right. So how many people have that? So we need we need to consider that chief the C might be capital sometime, and then the whole thing might be capital sometime, or sometime the whole thing might be lowercase sometime. So we need to make sure that we convert whatever job title is, we convert that to a lowercase first or uppercase, and then now we can now see if the word chief is in the job title. So you transfer the job title to lowercase, for example, right? And then you will see if the lowercase chief is in there when we want to return true. If it's not there, we want to return false. So that will be a function. And then we are going to apply that function to our job title. Right, so def, I will say string or chief string, chief string. So it will take a title, job title. Let me just put title here. So I will say for chief, if chief, let's put the condition, if this lowercase chief is in in the title. So I will do title that lower. So that will convert every title to lowercase because my chief is in lowercase. If that is that, I want to return true. Else, return false. Right, so this is our chief string. Now we are going to apply that to our job title, right? And then we want to count them. Because we want to count them, we apply the sum to it. So everything will be inside here, right? So I take my df, right, at the job title. Now I will apply this function in there. So I'll call lambda, and then x. And then I will just apply chief string on x, chief string of x. Right. Okay. Job title again. Job title. Job title. Okay, this job title. Oh, I see that job title. Okay, you got that. So you got 627 people who got the word chief in their name. Let me print that out here. Oh, I'm gonna apply data frame to that. Data df. I want to apply data frame to this. Okay, see, all of these people got chief. Sometimes it's C is capital, the rest of them is lower, right? So let me look at the tail. Yeah, so you get chief there. Okay, so we want to know if there isn't any correlation between the length of the job title and the pay. Is there any relationship? So, right. So if you want to see whether or not there is a relationship between the length of a job title and the pay, then you can do the following. Right, so first is length of job title correlated to pay, total benefit pay. Okay, benefit, right, is it total pay benefit? So let's define a new column. So I'll say df title length. So that will take the length of your job title. So title underscore length or length. So that is equal to df at job title. And then we're going to apply the length function. Length return the length, right? Length is a method that returns the length. So I take the job title here, and then apply. I will apply this. Right. So now I want to compare the length of the job and then to the total benefit, right? So df are those two columns. So the first column is title length, and then the second column is total benefit pay, total benefit, total pay benefit. So this method, the core, will let you know correlation, right? The closer this number is close to 1, that means they are strongly correlated. If they're, negative, that means negative correlated. Close to 0, they're not correlated at all, right? So you see, if you look at length and total pay, this is negative. If you look at total pay, you look at the title, they are negatively correlated. These are not correlated at all. So the length of a job title has nothing to do with total pay, right? So there is a lot of stuff that we can do with pandas, but I'm gonna stop here and then move on to our next topic, which is web scraping. If I may. Any question? Okay. So I am going to open a new Jupyter notebook. Right, I'm here. Then I'll open a new Jupyter notebook. I will call it Introduction to Web Scraping. Okay, 1 second. Okay, so web scraping is just another fancy word of saying extracting data from the web, right? So there are many. What do you do the length function for correlation? I create a new column named the length of the job title. I was just measuring, right? Every job title, I was just getting the length of that, right? So it was just a practice to see if there was any relationship between how much work you have in your job title, if there is any relationship between that and the pay. Right. Just a fancy word for web scraping. So it's just another way of saying extracting data from the web. So let me open my Jupyter notebook. Okay, so for web scraping, we need to install some library. Let me go back here. So we need to import some library, like I think we need to install Beautiful Soup. Right. There is a lot of tool that will allow you to scrap the web page. But for time sensitive reason, we can just limit ourselves to beautiful soup, right? So we need to install this library. If you're using Windows, use Anaconda, you can use Conda install request, Conda install LXML, and then Conda install a beautiful soup. You can do that, or you can also install it here by saying pip install BS4. I will say beautiful soup. Or BS4.
And Professor Musa, so just to be on the same page, the material for this will be available on GitHub, right? Currently, we only have day 1, day 2.
Everything. I'm giving everything to Nana.
Okay, cool. Yeah, thanks.
Yeah, everything will be there. Okay, okay, so I will instead of that use BS4. Is for beautiful soup also. People install BS4. That should work like exactly here. Right. I think I got a request already. Let me import a request, but you need to install it. Right. I think I have it already. Yeah, I have it already. So we need this tool to scrap the web. So the first thing that I want to do is let me import beautiful soup also. I need to import libraries. I need to import the libraries that will allow me to scrap the web. So I import a request. I will also import BS4, right? So from BS4, I'm going to import from BS4, I will import beautiful soup as can you say SP or BS, beautiful soup. And I think these are enough. We got requests with the beautiful soup, these are enough, right? So the first thing that I want to do is to script Frederick Douglass Wikipedia page. So I will go to google.com. I will say Frederick Douglass. Right, Douglass. So if I search for Frederick Douglass, I'll look for the Wikipedia one. Basically, we can script anything that we want. Especially if you have the API. But Wikipedia seems to be more open source. That's what I'm going there. So I click on this. Can you see the browser that I just opened for Frederick Douglass? Okay, so this, I will copy this link, right? I want to do requests, right? I want to do requests to access this thing. So I will say my URL to this. So let's say I will define a variable called URL. So URL equal this string right here, right? Then I'm gonna do a request. So I will say my request or response equal request, right? That gets. So I'm getting, the information from this URL, right? So this is better than always copy and pasting this long URL here. So you just store it to this variable called URL. Right? So this is the request that I did. Right? So as a web scraper, you first need to make sure your request was granted, right? So you can do that by checking the study. right? So we started and okay. So I would say response that's start to underscore code, we started code. So 200 mean yes, 404 mean forbidden is not allowed. And then there is a lot of code name there. Let me see if I can get some web scraping code, static code. Yeah, static code. So you got a bunch of them basically. Let me see. Static code. I mean, yeah, static code. So 200 mean, you know, your request has been granted, but there is a way to get the code, web scraping, static code. Okay, so right, but 400 is bad. Let me see if I change this to 1s. Okay, maybe that doesn't do a lot. I will just make a fake address. Let's say URL f equal this dot I'm just trying to show you that you don't always get this. Let me see. Equal. Yes. Oh, you want me to try this link?
Just saying the status code. Yeah, that's a link for the list of status codes. But you don't. I don't want to drop. Yeah, I wanted you. This is just FYI. So you can go.
Okay.
Yeah.
Okay. So if I say the response is equal request that gets, so I want to say URL f equal. So I want to look at the response. That doesn't even exist, right? So let me see. Some website will not let you. Let me do response not spelled. Okay, response. Equal request that. Thank you. Let me get another web link, for example, that won't let me unless I have a correct API. Let me see it here. Some VADSTI, yeah. I want to look at some API. Web scraping, data science, web scraping. Okay, so let me say if I can just make up apple.com. I think that's a correct thing. So I will say https://apple.com, for example. Okay, so I want to look at my response. Response that static underscore code. Static code. See? Oh, they allow me to. Wow, I'm surprised. What about item? But this is not Apple, it's Apple. Okay, are you referring to? No, there is a robot text. There is also static code, right? So let me look at if the response was okay. Response that okay. It should be true. Yeah. Okay. So then let me do it. Let me look at the iTunes. What's the web page for iTunes? iTunes. Okay, Apple iTunes. Let me copy this, paste it here. I will say, Friday, let me do this. Wow, I'm able to get all of this. Maybe this is in the memory. I don't buy this. Let me clear the memory. I want to clear all of it. Right, so I'm going to start over. I got this. I got this already. So this is fine. Douglas, I got 200 code, but I want to get this. Huh? Okay, then I can skip this. Okay, good to know. Anyway, there is some website that have a restriction, they don't let you go. So you get 404 here. I was trying to get some example. Data science. Some examples where you don't get so let me do this. Exchange rates. Right, you can script the web exchange rates. Exchange rates. Let me do this. Exchange rates. Place it here. So if I'm allowed to do all of these with the API key, I'm famous today. Wow. Okay. All right. So I'm gonna check all of these. Exchange rate. Usually you will need an API key to do this. But believe me, as you scrape the web, you will not get 200 all the time. You get 404, right? 400 and so on. Right? All of those numbers has a meaning. Now, I want to get Frederick Douglass picture. I want to get these to my local computer, for example. So if I want to grab these, I can come here, right click and inspect, click on inspect. Right. So this will tell me that Douglas picture is in this HTML code here. But what I'm interested is the class that it is in there. So I can just grab that class key, right, with so I see these. Let me go up a little bit. There is a class here, info box, that also have it. So class, I can grab it by class. There is a table data with key called span, but I can grab a class key also, info span. So this is how you do it. You want to grab something on the web, you need to inspect to make sure that you are grabbing the correct item, right? So if I come here, I know I'm outside the picture. Down here, I'm outside the picture, right? I'm down. So you gotta, hover over it. So the Douglas picture is around here. So usually you come to the exact location that you want, and then you inspect it, which we have here. So I wanna use the knowledge that I got here to grab this picture. So,
Mr. Musa, could you please paste the URL in the chat?
You paste a URL in the chat?
No, the Frederick Douglass Wikipedia.
Oh, let me put it right now.
Yes. Yeah, it's giving me a head.
Yeah, let me give you right now. So this is the one that I'm using. Hope everybody can see it. So now I want to grab the picture only, right? So that will not be the only thing that I will grab. I'll be, in fact, I'm gonna grab the whole thing first. So I will call the data frame. I call that. It's okay, they give me 200, that means green light, go ahead, get whatever you want, right? So now I want to, make this one prettier. Right now, if you look at it, it's difficult to read. So where is my Jupyter notebook? I think it's right here. So I'm gonna build a soup object of this response. So I will say soup is equal our beautiful soup. So BS, I'm gonna apply that to our response that text. So if you check that response.text, right, I want to use the parser called LXML, right? There are many, I think there are HTML5 lib, right? But this one is the one that I'm going to stick with it. So here, let me do response.text so that you can see it is not that nice. Response, what am I doing? Response, yes, dot text. See, this is not, as a human, this doesn't look nice to us. So we need to make it readable. Right? So first we build this soup object of it to get the HTML text of it. So you look at it, it is an HTML document because it starts with this. Every HTML document starts with this type HTML, right? So here, I forgot to mention, to scrape a web page, you need to be a little bit familiar with HTML keys, syntax, right? You need to know what's a table data, the paragraph, what's a link, right? Image, stuff like that, because you have to recognize those and then go after it and grab them, right? So this is good, right? Because all we need to do, if we want something, we go to the main, the original page. For example, I want the picture, I'll go there, I'll figure it out, what class or what table or what div is in there. Once I know that, then I will grab that. I will grab that particular information. Once I grab that, then I will be able to get exactly what I want, right? So let's do that. So this thing is in what class? So let's look at it. It's in the class called infobox.image. That has extra, right? That have extra. I want to get exactly the picture. I don't want anything extra to it. Let me go up here. Oh, so this will give me all the info box, but I'm not interested in that. I'm just gonna grab this part. Yeah, class equal info box image. Yeah, I'm gonna grab that. This, if I hover on that, you see it got only the image, right? So that's what I'm going to do. Right, so I will say info box / image. So let me do that. I will say my picture. Let me go back to, I will say my picture is equal, right? We're gonna get the soup. Soup got a method called find. Right? So I'm not gonna look for find all. I wanna get only the one that have a particular. So class is a keyword. If I don't use this, it would not work. So I would say class equal this info box believe image/image. If these don't match, then I will not get exactly what I want. Let me go back and check. So where was I? Yeah, info box image right here. Info box/image. So let me run that. Right, I want to run that and look at it. So my pick, right? So I want to look at this object to see exactly what's in there, right? My info box. So it's my pick now. Let me run it. Okay. So what I'm going to do, it has a binary. This is full of binary stuff. So what I'm going to do, I'm going to look at yeah, somebody got a text me. Let me look at that. Info box. Oh, I got typo there. Yeah. Ha. Thank you. Okay, so now let me look at it. My pick. My image link. Let me look at my image link. So let me look at this, the contents. Okay, it has no contents. It has a binary text in there. So let me look at that part. Let me see if I can see it here. Okay. Info box. Let me look for info box vCar. Okay. Okay. So let me take this because I'm trying to get the link of that will be. Let me take this instead of image. I want to change it to vCard. vCard. Let me come here, and then I will vCard. That's another class, and let me look at that. Why it is not printing? Fine. Info box. Okay, that's vCard. Info box dash vCard. Is it space only? Let me look at it. I think it's space only. Yeah. Oh, okay. So let me go back. Is it space or the info box vCard? Yeah, space only. Okay, why my thing is not appearing? Let me. Class equal vCard. Class info box class equal vCard. Okay, let me clear this again. Clear all output and run all. Let me see what's up. Okay, I'll run it again. Let me see. These, I'll just select them. I don't need them. Control, Command all. Okay, so pick on that. Info box that find all. Let me do all. Find all. There is no class that have that name. Is that right? That's what he's saying. What is this? Okay, so there is another way to get these. We can call it the following way. So because it is a class, we just said that info box. So let me see that. If that doesn't work, then we can. So like this, where it is a class, we do that here. Info box class. Okay. But it is a class. This is a class. What is it? Or table class equal that. Okay, we can now grab it a different way, right? So we can grab it another way. So we're gonna say table and then class and then the key. So table here, right? And then dictionary, the class and the key. Do the class here. So class. And then key. So dictionary, class key. Okay. Oh. Control Z. So the key is info box. Info box vcar. Okay, why this is not table? Okay. Okay, so let me look at that. Just say one of them, not all of them. Okay, somebody got a text. Result in info box image. Okay, let me do that info box image. You got a result with that? Is that right, Williams? Info box image. So class equal info box image. Info box image. Let me see why. Here it is now. Let me say all. They say empty. Okay, so what I'm going to do, I'm not going to grab by that class. It's saying that it doesn't exist, but it does. So let me look for. So here, I can grab by IMG, right? So IMG alt equal Frederick Douglass, right? So let me see, can I copy these? No. Right. So I can download that, but usually class is easier. So class is easier to grab. Okay, so what I'm going to do, I'm gonna grab just the link, because I know there is a link here that contains these. So define all A. Okay, so I got a bunch of link. I just need to find the link that will contain Douglas. So links start with href. Title for the ask question, blank, 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 blank. Get API. So we can continue with this tomorrow and say that it's two, but this is the hard way. Usually, this is a good way to do it. You come here and then you inspect it, and then whatever class is in there or dive is in there, you grab it. But that, I don't know why, maybe I'm tired what I'm doing wrong here. So you grab by those classes or those, if it is inside div, you grab that, right? So I even went further, tried to grab it by this class, but it is not. But this one does work, but it is hard because you have a bunch of links. You have a lot of links here, right? It's a list. In fact, if you can look at how many are there, there's somebody has, you got 51 links in there. So one of them will contain, how about using regular expression? Yeah, that too. That too. So Williams, you got your results? I can't hear you.
Yeah, it didn't come because what I actually did was I did a right mouse click and copy the XPath, and that also didn't come. Yeah, so there may be something in there because the thing is it didn't error. It didn't error, which
yeah. That's weird. We're gonna continue with this tomorrow and then do data visualization. I think that will be it. I'm gonna figure it out before tomorrow. Why it's not showing? Because I did this. I tried before. I even did it with a lot of people, a lot of famous people. You just grab by class or by div or by A and stuff like that. So thanks for your patience.
Okay, cool. So I guess it's two, and we had a great session, and the material will also be available so that you can go through. And that's with coding, you have to hit your head here and there, and that's what makes you a mature coder. Yeah. So thanks so much, Dr. Musa. A lot of materials. We'll go right, and then we'll see you tomorrow. A little bit of house cleaning. Remember to do the set. No, the survey will be for tomorrow. But I think there are two things that I have on my list to remember. Let me get it. I typed it in here. Yeah. So we have the sign-in. We have the video will be out tomorrow, and then we have office hours. So Dr. Ibel and myself will be having the office hours. For the weekdays, please reach out to Dr. Ibel. I can do that by sending an email or through Slack, or just reach out to Stacy. For the Saturday office hours, it's definitely going to happen if anyone shows up or not. We usually have 1 or 2 people showing up, and that will be 6 to 7 Saturday Eastern. That's New York, Washington, D.C. time. So thanks so much, Dr. Musa, and we'll reconvene tomorrow at 11.
All right. Thanks, everybody.
Thank you.
Thank you.